So, for Chapter 9, Lesson 1, we are going to be solving systems of equations. Now, the first 4 examples that I'm going to do is really a review of Algebra 1. You did this, you learned the substitution method, you learned the elimination method. They also, in Algebra 1, made you graph them. So, when we solve systems of linear equations, we have 3 different scenarios that can occur. We can either actually graph 2 totally different graphs, and then their solution is going to be the point of intersection, or where the 2 lines cross. So whenever there is 2 totally different lines, and there's only one solution, we're going to say that this system is consistent. Now, when you have 2 equations, and if you were to graph them, and those lines end up being parallel, then you can see that they never cross. So there are no intersecting points. So this would have no solution. So when the lines are parallel, it's no solution, and you would describe this system as being inconsistent. Then when you go to graph it, or if you were to solve it, and it turns into exactly the same line, then we can say that there are infinitely many solutions because the 2 lines are on top of each other. And you could either write your answer as all real numbers, you could write the R, you could put from negative infinity to positive infinity, and then for the no solution one, you would just put the circle with the slash. So you're going to have 3 different scenarios. It's either going to be all real numbers, no solution, or one solution. And you will list what that one solution is, and you're going to list it as an ordered pair. So let's go try the first method that you learned back in Algebra 1. This is called the substitution method. And with the substitution method, what we need to do is take one of our equations and solve it or rearrange it for either x or y. Now, when I teach this to my Algebra 1 students, I tell them, pick the equation that doesn't have a number in front of x or y, because then we don't have to deal with a fraction. So I'm going to work with my second equation, and really technically I could solve it for either x or y.
But wouldn't it be better solve for y because x is really negative?
Yes. Yes. So a lot of students always think, I just got to put it in y equals mx plus b form, which you could do that. But what Lily just said, it's better if we just solve for y, because if I just add the x to the other side, now my y is positive, and this is what y equals, x plus 3. So once I've rearranged one of my equations, I now take the other equation, I'm going to write it down, and now I am going to substitute what y equals, which is this x plus 3, and I'm going to put it here in place of the y. So I'm going to rewrite the 3x, put the 2. In place of y, I'm now putting x plus 3. So now I don't have 2 different variables in my equation. And now I can distribute, combine like terms, and find x. So I'll distribute the 2, drop down the 3x, drop down the 11. I now need to combine my like terms and solve this equation for x. So this becomes 5x plus 6 equals 11. Subtract 6. 5x equals 5. Divide by 5. And x equals 1. Now remember, I told you that when you have 2 equations or solving the system, the answer is an ordered pair. I only have part of my ordered pair. So now to find the y, I'm going to go back and plug it into one of my beginning equations. Now, you can plug it back into the original 2. It doesn't matter which. You could even plug it into the one that you rearranged, which in this case is going to be a lot simpler. I always choose the equation that's going to give me the least amount of work. So I'm going to actually plug it into my rearranged one. So I take out x. And I'm going to put in 1. And then 1 plus 3 gives me 4. So you can plug it into the rearranged one. And that's your solution to your system.
If you plug
Is
it
there
in,
one? Oh, yeah.
if you plug it into any of the three, you get the same answer.
Yes. It doesn't matter where you plug it in, you'll still get the same answer. Now, what I always tell my Algebra 1 students, if there's time on your test and quiz,
Plug it in.
plug it in. It must work for both. Now, it's pretty quick to plug this in, but if you already take a lot of time for a test or a quiz, I would solve them all first, and then if there's time, go back and plug it in. So I'm going to rewrite both, and I'm going to show you how we're going to plug it in. This will save your signs. For this, you really need to stay nice, neat, and organized because you may forget what you solved for. Like, let's say I didn't label that as x equals 1 in my first solving process, and then I plug that in for y. Then it's going to mess up my answer. So you need to stay nice and neat and then remember what you're solving for. So I'm going to plug in the 1 and the 4 because remember in your order pair, the first number is x, the second number is y. So 3 times 1 plus 2 times 4. If when I do this left side, if it doesn't equal 11, I need to go back and redo my problem because I did something wrong. But notice so far, looks good, 11 equals 11. It must check for both, so let me plug in this one. And again, once I plug that in, I do get 3 equals 3. So the order pair, 1, 4, is the solution to this system. So if I were to graph these, the point where they would cross and make that x would be the order pair 1, 4. So this is the substitution method. Now when you did this in Algebra 1, they made you graph it first. That was probably like lesson 1 in the chapter. Then lesson 2 was this, and then lesson 3 into the elimination method. Now, in here it says you could either add or subtract the two equations. I always like to think about adding them. And what I'm going to do is, if my x or y's don't have one positive, one negative sign, I multiply it by -1. So that way they cancel. So for the elimination method, you have to decide which variable you want to eliminate. It doesn't matter which one you choose to do first. Again, I always look for the variable that's gonna give me the least amount of work. Here, when I go to eliminate x, I would need to make the 3x and the 2x have the same number but opposite signs. So what I'm really doing here is finding a least common multiple between 3 and 2. So actually what I can do is change them into 6 and -6, and then I can multiply the entire equation by a number to make them those.
Multiply the first equation by 2.
Exactly. So I'm going to multiply my first equation by 2 and the second one by -3. Now if I wanted to eliminate y, I would make them both become 12s. Again, it doesn't matter which one you eliminate. You're still going to get the same answer.
But you have to multiply the answer too by...
Correct. So you need to multiply all 3 pieces. Everybody always forgets about that right side of the equal sign, that answer. It needs to go to all 3 pieces. So this will become 6x minus 8y equals 2. And then the bottom one will become -6x minus 9y equals -36. Now that I have one of my variables, either the x or the y, to have the same number but opposite signs, now I can add my equations together. Notice when I add 6 plus -6, the x cancels. I'm now going to add -8y plus -9y, and that gives me -17y. And then 2 plus -36, and now I'll divide by -17, and y equals +2. Again, remember your solution is in order pair, so now you need to take what y equals, go back to the beginning. Now, you could plug it into one of the ones that you multiplied, but the beginning ones are smaller. So I would plug it into one of the beginning ones. I'm just going to go ahead and plug it into the top one. So I'm going to use the 3x minus 4y equals 1. Again, it doesn't matter which. You'll get the same answer either way. So once I plug in for y, multiply, and I get negative 8 or minus 8, and then add the 8, and then divide by 3. So 3x equals 9, x equals 3. Again, your answer is an ordered pair. So 3, 2. The x goes first, the y goes second. So that is an example of solving a system using elimination. I'm actually going to do the next 2 examples using elimination. Now, you can choose whatever method you're more comfortable using. However, when we do the 3 equations and the 3 unknowns, you're going to have to do combinations of both to solve these. So let's try the next example. So these 2 examples that I did were an example of one solution, meaning one order pair. The next 2 examples I'm going to do are the no solution and the infinitely many. So again, process is still the same. I can go ahead and use elimination method. I am going to try to eliminate x, so I'm going to multiply my first equation by 2. I'm going to multiply this one by 2. So my new equation will become 6x minus 4y equals 8. I'm going to write the second equation underneath. Now notice I thought I was only eliminating x, but really I'm eliminating y also here. So I'm going to go ahead and add them up. The x's canceled, the y's canceled. Now when they're canceling, what's left behind is 0. So I have 0 on the left, and then 8 plus 7 is 15. Once your variables, both of them cancel away, and you're left with a false statement, this is when the answer is no solution.
Are we ever gonna have it where like it cancels and like they equal 0 but your other side equals 0 too?
That's the next example. And that's when it's going to be infinitely many.
Okay.
So when it's a true statement that's left behind, then that will be infinitely many. So again, you're also going to be seeing that this is also described as an inconsistent system. So when you have no solution, it's inconsistent. So for the next one, I'm going to do the same thing. I'm going to multiply my second equation by 2. So let me rewrite the top one. And then the bottom one becomes negative 8x plus 2y equals 4. Notice this time I got zeros on both sides of my equation. This is a true statement. So when everything cancels and you're left with a true statement, then the answer here is all real numbers. So you could write it as negative infinity to positive infinity. You could put this capital R with the 2 lines going down. You could even write out all real numbers. Just indicate that this isn't all real numbers or infinitely many solutions. This actually, if you were to rearrange these both into y equals mx plus b, you would find out that this is going to be the same line or the same equation. And when this occurs, the other vocab word is, you would describe this as a dependent system because it's depending on the other one to be the same. So that is the review of the Algebra 1, substitution and elimination. Now what we're going to see are some examples of solving equations with 3 unknowns. So when we solve these, our solutions, instead of ordered pairs, they're going to be called ordered triples. when we go to write our answers, we're gonna put them in ABC order. So if we're solving for an X, a Y, and a Z, that's how you're gonna list it, as an ordered triple. Now, when we go to start this process, we're gonna be pairing up two equations at a time. And we're gonna try to eliminate one of the letters. Whatever letter you decide to eliminate must be the same for both sets. I'm gonna show you what I mean by that. That's this caution here. So here is my first system. Notice there are 3 equations and 3 unknowns. I'm still using the techniques that I just showed you when there were 2 unknowns. However, I'm gonna work with this 2 at a time. So really what I wanna do is find my pivot equation, or my equation that I'm gonna use in both pairs. So for example, I am going to try to eliminate the variable, I'm gonna try to eliminate Z. So what I'm gonna do is I'm gonna add equation 1 and 2 together.
Pardon interruption. Tangita Suku, please report student services. Tangita Suku, please report student services.
Okay, so I'm going to be, let me rewrite it some. I'm gonna add equations 1 plus 2 to eliminate Z, and then 2 plus 3. Now notice when I do 2 and 3, I don't need to do anything to them to eliminate the Z. However, when I go to add 1 and 2, in order to eliminate Z, what I need to do here is multiply my second equation by 6.
How do you know which to use your pivot equation?
All right, you can choose whatever you want. Like for example, let's say you wanted to eliminate Y. So you could, if I want to eliminate Y though, I'm gonna have to multiply not only by a 9 when I do it with one of them, like a -9, but then I'm also gonna have to multiply one of them by a -1. So really what you wanna try to do is find the equations that you can add together that's gonna make you do the least amount of work. There's no right or wrong answer here. So I chose Z because I could get away, right. So you can see how, if you already see one variable that already has 1 plus, 1 minus, I would start there. So that's why I could see right away 2 and 3, if I number these, like let's say this is 1, this is 2, this is 3, I can already see when I add 2 and 3 together, it's gonna eliminate my Z for me. Then when I go back, again, one of the numbers needs to stay the same in both. So 2 is staying the same in both for mine. So now in order to eliminate Z, when I add 1 and 2, I need to make this Z become a 6. So it eliminates. So let's go ahead and multiply equation number 2 by 6. So let me rewrite it here. 2x plus y minus z equals 2. I'm going to distribute 6 to everything, including the answer. And this is now my new equation for number 2. I'm now going to add that to the original number 1. So the 3x, and I'm going to line it up. And now I can add the 2 equations together. All right, so when I add these, I get 15x plus 15y equals 15. Now, I could also reduce that and divide them all by 15 and just make it x plus y equals 1.
Does it matter which one, like, so you see how you put the second equation on top instead of the first one? Does it matter?
No, it doesn't matter. Just line them up. So the x's are on top of each other, the y's, just like that. All right, now I need to do 2 and 3. Now I'm gonna reserve this and I'm gonna hold this off to the side for now. Now I need to work with 2 and 3 together. So 2 and 3, I don't need to multiply by anything because my z's are automatically gonna cancel when I go to add those. So I'm gonna use the original on both 2 and 3. So 2x plus y minus z equals 2. And then x plus y plus z equals 2. I'm going to add these up. When I add these, I get 3x plus 2y. The z's cancel, equals 4. Now, these two things look like what I just showed you at the beginning, the first 4 examples. So now I have a simple system with 2 variables. And again, I can use one of the methods that I just showed you. I can either do substitution or elimination because I want to solve for x or y. I'm actually going to do elimination, and I'm going to eliminate y. I could eliminate x, it doesn't matter. Again, there's no right or wrong one to solve for first. So what I'm going to do is I'm going to multiply my first equation by -2. So that new equation that I'm going to get, I'm going to write the answer down here, is -2x minus 2y equals -2. All right, so now I add those two equations together, and I get x equals, the y's cancel, x equals 2. I've already found one number for my triple. So now I work backwards. I'm going back up now. I'm now going to take that x equals 2, and I can either plug it into this one or this one to get y. Doesn't matter which. I'm going to go to the left side because that's going to give me the least amount of work. So I'm going to plug it in, x plus y equals 1. I'm going to put 2 for the x, and now I'm going to solve for y. And y equals -1. I now need to go up one more time to the very beginning because now I need to find z. I already have 2 of them. So I go way back to the original. It doesn't matter which one of these I plug it into, the x and the y, to get my z. I'm going to do the bottom one because see how it's got the least amount of multiplication and stuff going on? So that's where I'm going to plug it in. So let me write it down here. So x plus y plus z equals 2. I take out x, I put in 2. I take out y, put -1. I leave the z, because that's what I'm solving for. Combine my like terms. Move the 1 over, and z equals 1. So my triple is now 2, -1, +1. Again, in A, B, C order, X, Y, Z. Again, you can do the check here, but you need to plug it back in to all 3. Again, it must work for all 3, or you've done something wrong and you need to start over again. Okay, let's try the next one. One more. Again, your homework over the weekend is not the 3 unknowns, it's just the 2 unknowns. Monday night's homework is the 3 unknowns. Yes?
So that's basically like the matrices?
The matrices are gonna be put into an array without the variables, just the coefficients.
If we understand that.
It'll help you.
Okay.
Yes. So we'll be manipulating the arrays or the matrices. All right, let's try the next one. Again, you can choose what you want. Notice my y's and my z's have very similar, it's either a 1 or a -1. This time, what I'm going to try to eliminate is y. Because see how I've already with equations, if I number these 1, 2, and 3, already with 1 and 2, I can already eliminate the z without multiplying anything. The y, yes, the y, thank you. And then I'm going to also, so the one that's going to be in common for me is going to be 1. So then I'm going to add 1 to 3 also. So let's line them up. So 2x plus y plus z equals 9. Then I'm going to write 2 underneath it. And then when I add these up, the y's cancel. And then I get x plus 2z equals 10. I'm going to leave that one alone for now. Now I'm going to add the 1 and the 3. However, before I can add the 1 and the 3, I'm going to multiply one of them by -1 so it cancels. So I am going to multiply, let's see, which one? Doesn't really matter. I'm going to, I'll multiply, do I have to multiply them? No, I don't. They're already set. All right, I didn't need to do anything on this one. This one was super easy. All right, so 2x plus y plus z equals 9. And then write 3 underneath it. 3x minus y plus z equals 9. The y's cancel. And I get 5x plus 2z equals 18. I know. That's why I usually put the little cross, the little line through it. Okay, so now I need to go back and eliminate either x or y here. So notice my z's, or sorry, not x or y, x or z. So my z's have 2's in front. So I'm going to multiply one of my equations by -1 to get it to eliminate. So I'm going to actually multiply this red one by -1. So if I multiply that by -1, let me rewrite the blue one, and then I'm going to write the answer to the red one underneath it. So this will become -x minus 2z equals -10. So this is the answer to the multiplication. I'm now going to add my equations. So 5x minus 1x is 4x. This will cancel. And then I get equals 8. Divide by 4, and x equals 2. I now need to work back up and plug it in to the step just above. Again, I can plug it into the left one or the right one. It doesn't matter. I'm going to plug it into the left one because, again, it's got less multiplication going on. So 2x plus 2z equals 10. I'm going to take out x, put in the 2, move the 2 over, divide by 2, and z equals 4. Now to find y, I got to go all the way to the beginning. And again, it doesn't matter which one of the 3 you choose. You're still going to get the same answer. So I think I'll do the middle one. So the middle one was -x minus y plus z equals 1. So x put in there, y I don't know, z is 4. And now combine like terms and solve. So -y, divide by -1. I don't want a -y, so that becomes +1. So my final triple answer here in x, y, z order is going to be 2, 1, and 4. So again, you could plug it back in to make sure it works. I highly recommend that if there's time on your test or quiz. Now in the homework, the answers, let me just show you something from the textbook. So here is the homework, 74, 794, 795, which I just showed you, 19 through 37 odd. So again, for 31 through 37, you're only saying if it's no solution and inconsistent or all real numbers, so like this, and dependent for those questions. Don't worry about the y arbitrary. You don't have to list that.